All right, good night to everyone. Can you guys see my screen?
Good night, sir. Yes.
All right. So we're going to continue content as we lead up to your exam. We're going to finish off programming and then we're going to go back to web page design to finish off the content for that. And then we're going to start working past papers. So basically, we already covered all of this. We even covered it for your SBA. We basically looked at how to do problem definition, what is the algorithm phase, what is the implementation phase, how to create an algorithm. You guys did that practically. Implementation phase, you did that when you converted the algorithm into a program. And we already went through what is the IPO chart. Remember, if you have any questions at any point in time, the session is for you. So if you don't ask any questions, I can only assume that you're following. So we should know what is the difference between a variable and a constant. You used it in your pseudocode, you used it in your program. It's basically a method to store data. That is how your program stores data in variables and constants. A variable, as the name implies, it changes throughout the program. The value changes throughout the program, whereas a constant, which is a type of variable, does not change. A constant does not change. It stores a value, but it does not change. Um, Variables have certain types, just like how you guys have types. So we have integer, we have real, we have character, we have string, we have boolean. So it's important to remember what are the characteristics of each type. Each type is different, each type is special. So integer is only whole numbers, real has fractional numbers, character is one character, string is a multiple, boolean is only two options. What is a statement and a keyword? That's basically an action word. Think of it like a verb. In programming, statements and keywords are our verbs. Think of it that way. They tell you what is happening. Input simply means something is going in. Output means something is coming out. When you are writing your program, you use the write keyword. WRITE. That keyword indicates that you are putting something into the program. You're putting something out. Read indicates that you are putting something into the program. Conditional statements, that is our if statements. Loops, that is while, repeat, and for. For loop. We looked at all of those loops. What is a subroutine? A reminder, what is a subroutine? It basically means taking a large program and breaking it up into parts. Part 1, part 2, part 3, and so on. So I can say, Pamala, you work on part 1, Arifa work on part 2, Deringer work on part 3. And we merge it together to get one final program. Those parts are called subroutine, functions, module, procedures, and so on. We went through this entire chapter here, how to design a pseudocode. So we're not going to go through that. I think we started this here. Did we finish it? Anybody remember if we finished it? Or should we go through it?
Sir, I think we finished it, but could you please go over it again?
All right, no problem. So the flow chart is basically an algorithm. So if we can remember, an algorithm is basically a series of steps. An algorithm is a step-by-step guide that leads you to a solution. It tells you what to do to get to a solution. Like for example, your pseudocode, that was step by step. It tells you exactly what to do. Step 1, put this into the program. Step 2, do this. Step 3, do that, and so on, all the way to the end to get to your solution. The pseudocode is in English form, whereas your flowchart is in a diagram form. So as you can see with these examples here, we're basically not seeing sentences, but we're seeing more of shapes. We have to memorize what each shape represents. A oval is a terminator indicating start and stop. So you guys should remember from your pseudocode, you had a start or a begin, and you had an end or a stop. So in the flowchart, you're going to use this symbol here because they might ask you in the exam to draw a flowchart. So you have to use this symbol here and put start inside of it to indicate that's the start. Or you put stop at the end to indicate that is the end of your pseudocode. So like this example here, we have start and we have stop. The parallelogram is used for input and output. Everything that has to be put into the program, everything that has to come out of the program is represented in this shape here. Doesn't matter if it is input or output. It is represented by this one shape. So for example, this one here, we have to input 3 value into 3 variable. Number 1, 2, and 3. We're putting in 3 values. So we simply say keyword input and store into what variable in that shape. When we're doing a calculation, when we're doing some sort of process, it's going to be in a rectangle. So for example here, this is a process input. So process, add number 1 plus number 2 plus number 3. So any form of calculation goes in a rectangle. Our if statement, our conditional statement always goes in a diamond, because the diamond, the points are used for branches. So the points in the diamond are used for the branch. A point is not dedicated to true or false. It's not dedicated to yes or no. It's all up to how you design it. So you could say that this one here is no, and you could say this one here is yes. That's all up to you. The path is up to you. So, but you would have to specify it that if mark is greater than 80, if it is yes, go this way, stop the program. If it is no, if it is false, go this way, do this, do that. You would have to specify that. So a diamond is for your if, your conditional statements. If a test, always ask in a question format. Remember that. Always ask in a question format. Is it greater? Is it less? Is it equal to? And then you ask, is it true or is it false? The circle is used as a connector. So if 2 reasons why you would have a connector. 1, this is related to the subroutine. When we were talking about breaking your program up into pieces, so say for instance, the program from here to here might have a subroutine like this here, just representing it like this. So these programs here are going to be built like this here. So these circles indicate that they can be connected to each other basically. So they're like individual parts. So this is one part of the program. And the circle indicates that I can connect it to a certain part of the another flow chart. And this here is going to connect to another part of the flow chart. So as the name implies, it's indicating that you can connect it to another flow chart. And then you have your flow lines, which indicate the direction of the data. So how the data is flowing. Like for example, we can see the data is flowing straight downward. But here, we can see how we can take turns and go in different direction. Like for example, there's one where it goes back up. So notice this one here. When it reaches this test there, notice it goes back up. So it shows that when we come down this way, we come back up into the test and run again. So that might be an indication of a loop, that we run a loop there. So if in a flow chart, so yeah, that's a good one there. If in a flow chart, you notice that there's basically what appears to be like a literal loop. You see it going around like this here. That's an indication that there could be a loop, basically. So that is the symbols there in the flow chart. Any other questions from anyone? The flow chart, it's relatively easy to follow. You just have to go one shape at a time. You start, go over the loop part, I'll come back to that. So you start, you look at the shape, try to understand what's happening at the shape. You input a mark, input 80. You go to the next shape. You try to figure out what's happening at the shape. This is a condition. Is 80 greater than 80? Yes. So we come down here, we ignore this part here, and we go down. We follow the line. So it's just as simple as to read what's happening in the boxes and follow their instructions. All right, so let's go through this one here. Now, it doesn't say it is a loop, but the fact that it's repeating a certain part, we can consider it a loop because we are going to start and we are going to initialize this variable number with a value of 1. Now we're going to go to the decision and we're going to ask ourselves, is 1 less than equal to 3? That is going to be true. So that's yes. We come down here. So next we have to do add 1 plus 1. That's going to be 2. So we output that number 2. And then we go back up here because we got to follow the line. So the fact that we are repeating this step here is an indication we are running a loop. There is no keyword here saying repeat loop, while loop, for loop. But the fact that the line taking us back to a previous step indicates that is a loop. And then, so now, this here is going to have a 2 inside of it. Please note, what I'm doing here is called tracing. Just like how you guys created a trace table, this is also called tracing. So I'm tracing what is happening to the flow chart. Or if it was a pseudocode, I'm tracing the pseudocode. So it's important for you to write down what is happening at each step so that you can trace it properly. Is 2 less than equal to 3? Yes, once again. So now we got to add 2 plus 1. Now we're going to get 3. We output 3. We go back up again. 3 is at the top here again. Is 3 less than equal to 3? Yes. We come back down. We add 3 plus 1. We're going to get 4. We output 4. We go back up again. Is 4 less than equal to 3? No. And we come out here and we stop the program. So the fact that steps are repeating itself is the indication of a loop. Did that help you, Arifa? Great. Was also going to help you to remember the same thing, the same concepts that we learned in your pseudocode is the same concepts in your flowchart. Does that? It's in a diagram format. So what can help you to remember if you have a loop is if you remember what is the 4 things a loop has. That's in chapter 9.3. All loops have these 4 things here, these 4 components. It has a variable. So if we look at this one here, the flowchart that we're just going through, it has a variable called number. So that's the first component there. Then we got to test that variable. So that's this diamond here. We're testing to see if it's less than 3. Then we have to execute the body. So after we finish the test, this is the body here. So that's 2, that's 3. And then we have to update the variable 4. So notice the update is here. So we have all 4 of those components there that makes up a loop. Variable, testing the variable, body of the loop, and updating that variable. We can go through this example here. So we have start, sum equals 0, count equal 1, and then we have a decision here. Is count an even number? So is 1 an even number? False. So we come out here, go down here. Remember, we're following the arrow, and we come down here. So we have to do 1 plus 1. That's going to give us 2. Now we come down here. Is 2 greater than 6? False. So we got to go back up. And then we come back here. Come back to the test. Is count an even number? So we got 2 there. That's going to be true. And we come down here. And we do this. And we keep going like this here. So the question is this a loop? Even though we're taking different paths, eventually we're going to go false and true, false and true. Is it still a loop?
Yes, sir.
Yes. Remember, a loop is basically repeating something. So even though you might go in different direction, like maybe you can say you're going like an 8, you're still repeating. You're still going in that same path over and over. So once you're repeating steps, that is still a loop. Good. That's basically it for flowcharts. Any questions before we move off? All right, so our new chapter, chapter 9.5, we are looking at arithmetic, relational, and logic operators. The different type of operators that we have, basically when we're doing calculation. This is not only for programming. These operators are also used in maths. You're supposed to actually know about them. The arithmetic operators, those are the common ones that you guys know about. Addition, multiplication, division, and so on. Relational operators, that's your more than, less than, more than, equal to, and so on. That we call them relational because we are relating two things to each other. we are comparing two things to each other. So they're called relational operators. And then we have what are called logical operators. These ones are a bit more complicated, the logic operators. All right, so let's go through the chapter. Remember, if at any point in time you have a question, let me know. So, in many of the examples in this chapter, you may have seen fragments of a pseudocode such as age less than 20, number less than 3. These conditions are evaluated in the arithmetic and logic unit of the CPU. Let us look at them in more detail. So, this is also important to note. This is third form work, that the CPU has two components, two main components. It actually has more, but it has two main components that you guys need to remember for your exam. Anybody knows what the two are? We have one here, the ALU, arithmetic and logic unit, good, and the control unit, very good. So those are the two units, yes, that make up the CPU. There is more. Let me show you them just in case it does, for some reason, come up in your exam. So these are the components of a CPU. So you have the control unit. What's happening? Control unit. The control unit is what controls the flow of data, you can see. All right, so what we can do, we can look at the arithmetic first. The arithmetic and logic unit controls all calculation. Anything that deals with addition, anything that deals with more than, less than, your logical operators, anything that deals with calculation, that is your ALU. Everything else is your control unit. So when you're transferring a file, when you're deleting a file, when you're moving something, anything else that doesn't relate to calculation is being handled by the control unit. Your CPU also has a component called the register. It has the cache, it has buses, and it has a clock. The clock is what is used to determine the speed of the CPU. The bus is basically, think of it like how many paths data has to travel in your CPU. So like literal bus, like how if you go to a park and you have like roads and buses. So imagine like this is your CPU. Say like this is a road, 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 and a bus can go on each one of these roads. So instead of calling it a road, we call it a bus. So data can travel across all of these buses. And so basically, data can travel much faster if we have more bus. A cache is simply built-in storage in the CPU. So somewhere on the CPU, like this here, is going to have a cache, built-in storage in the CPU. A register. What is a CPU register? Anybody knows? Can't remember it off of my head. Process the register quickly access location available. Register usually consists of small amounts of fast storage or something else. Okay, so it's just another area of the CPU that has a small amount of storage, whereby you can store memory locations. All these are very technical. So like I'm telling you guys that The main two that you need to remember is the CU and the ALU, but these are actually in reality other components of the CPU. But for your exam purposes, these are the main two. But sometime I have noticed that questions do magically bring up these terms here: registers, cache, buses, and clock. So just know that they're components of the CPU and what they actually do. All right, just give me a minute. I'll be back. Yes, I am back. So, as I said, those are the components of a CPU. Good. So, why we brought this up is because we're looking at operators, and the ALU is what handles all of those operators, what handles all of those calculations. So, our first operator is the arithmetic operator, and arithmetic operators are such as addition, subtraction, multiplication, and so on. So you got to remember the sign. Well, we should be familiar with them already. Plus, minus, asterisk for multiplication, forward slash for division. Please remember the direction of the slash. Don't confuse it with the backward or the backslash. Um, I've told you about modulus already. Modulus is represented by the percentage symbol. It gives you the remainder when you do division. So if you do 3 divided by 3, that is going to be 1. That's when you do division. But modulus is going to give you 0 because there is no remainder when you divide 3 by 3. So that's the difference between the two there. And then we have div. Integer division produces only the whole number. So it doesn't give you the remainder, only the whole number. So basically modulus, the three of them are division. Modulus only gives you the remainder, whereas div only gives you the whole number. It doesn't give you that remainder value. So you got to remember those operators and how they function. Are we following so far? Clear so far?
Yes, sir.
Remember, if you have any questions at any point in time, let me know. All right, so relational operators, as I mentioned, is basically comparing two values to each other. You will see these operators in algorithm where there is a condition. The algorithm relies on whether the result is true or false to know how to proceed to the next set of statements. This may include exiting a loop or jumping to another set of statements. So the relation operators are usually used for loops, if statements, and so on. So these are all of your relational relational operator. You have equal to, greater than equal to, less than equal to, and not equal to. So please remember the not equal to one. That might be the only one that is new to you. The rest should be very familiar. Now, the most complicated one, the logic operators. Now, the conditional, while, repeat, and for statements compare values in order to determine a result. For example, while number is less than 3, if mark is equal to -1, if age is less than 13. So they're all comparing one value with the other to see if it is true or false. So when the two values are compared using these operators, the result is either true or false. Now, let's look at the not operator. So when it comes to these, when it comes to these logic operators, there are a few types of them. Logic operators. Yeah, so these are the ones that you'll come across. So you have the AND, you have the OR, the NAND, the NOR, the XOR, the NXOR, the NOT, and so on. So I haven't really, can't remember if I've ever noticed them in an exam, but it would still be good for us to know about them. So the NOT operator. The result of a condition has two options. Examples are true or false, yes or no, accept or not accept. All right, so basically the not operator, it only has two states. True or false, yes or no, two options. Accept or not accept, 1 or 0. It only has two states. So for these operators, we usually create what is called a truth table. So the not, the and, and the or, we usually create them using a truth table. So for instance, let's look at this table here. So if the day is equal to Sunday, then if it is true, if we take this word true and we apply a not operator to it, we are going to get false. We're basically going to get the opposite. Now, let me try to simplify that. What we're simply doing here, think of it this way. We are taking one answer. So imagine this here as being A, and we are multiplying it by not. And when you multiply it by not, it turns it to the opposite. So that's what we're doing. That's what we're simply doing here. We're changing the value to the opposite value. Whenever you see not, not is the easiest one because not only has two value, either true or false, 1 or 0. So whenever you apply the not operator to a value, it changes it to the opposite. So like in this case here, what I just highlighted, if it is true on one side, if you apply the not operator, it's going to turn false on the other. So with this one over on the right hand side, if it is 1 on this side, if I apply the not operator, it's going to turn the opposite. It's going to turn to 0. Same for the bottom row. If it is 0, you apply the not operator, it's going to turn to the opposite. It's going to turn 1. Once again, if you have on, if you have the word on, and you you carry out the not operator, then the other value is going to be off. Think you guys clear on that? So It might sound complicated. It is complicated. It's not something you use on a regular basis, like how we just do the other two operators on a regular, like how we just use the relational operators and the arithmetic operators on a daily basis. The the not, the and, and the or, it's a bit more into computer science. So that's why I was basically saying I don't really see it that often, but still good for us to know for exam. So once again, the not is basically the opposite value. It's only two values. All right, so instead of me reading through all of that, let me just go to the table. Because basically you just have to understand the table. Now, ignore this last column. I don't want this column to confuse you because we only need three columns. We need column A, column B, and then this is the result from the operator. Think of it that way. So this is the AND operator. This is how the calculation is carried out. So you have two columns and you have to compare the values together. So that's why we have two columns. You have to compare the value in a row. Now it's very simple. Whenever you get two true, the result is always a true. Anything else other than that is a false. So notice, true and false is false. False and true is false. False and false is false. So you just have to remember this one line here, this one line. This is how I just remember it. You just have to remember true and true gives you true. Everything else is false. Every other pattern is false. Everything. So basically, if we had three column, if we had column C, and this one here was true, if all three of them were true, then the result is still going to be true because all the columns in that row is true. So only when all are true will you get true. Anything else, once there's a false inside of it anywhere, you're going to get false. Think you guys understand that?
Yes, sir.
I'm going to send you guys, looking for a simple one. Okay, this one here. So I'm going to send you guys this table later. Why is the table like that? Yeah, this is what I'm looking for. I'm going to send you guys this table later. And so it's going to help you to remember it. So let me open the image. So as I was telling you, the one that we looked at the first one, the not. So as I said, the not only has two values, only two states, 1 and 0, on and off, true and false, whatever the case may be. So the not is at the top right. So if you have 0 in one column, then the other column will be 1. If you have 1 in the one column, the other column will be 0. That's straightforward. The opposite. So as I said with and, in a true table, 1 is true. So you just got to take note of that or try to remember that. 1 is true. So true is 1. False is 0. So with the table, notice we're looking at the AND. So the one all the way on the left. So notice we have 2, 1, 1 and 1, and we get a 1. Any other combination, you get a 0. That's all you got to remember. 1 and 1, you get a 1. Or true and true, you get a true. Anything else, you get 0 or you get false. Now the OR is basically the opposite. The OR, 0 and 0 gives you a 0. Or simply, false and false gives you a false. Anything else gives you a 1. Any other combination gives you a 1. So if we look at that here, so forget about this column here once again. So notice at the bottom here, false and false gives you a false. So that's basically 0 and 0 gives you a 0. Any other combination gives you a 1 or a true. Think you guys understand that? Clear enough? And that's basically all you need to remember. That's basically it. So I won't really go through anything else. Those are the two main gates you need to remember. But you can still run through the image. I can go through it with you. It's basically just memorizing the table and how you get the answer. So XOR is basically, you just look for the pattern. XOR, if it has two same value, notice you're getting a 0. You're getting a false. And anything else gives you a true. And the XOR, or the, which one? The XNOR, this one here, the one on the right-hand side. It's basically two of them usually have like a opposite kind of table, if you notice. So that can also help you to remember them. So if you look at the AND and the OR, where's my pens? Let me put this inside of Paint so that I can draw on it. Yeah. So yeah, so you got to look for the pattern, and the pattern is going to help you to remember. So the AND and the OR are related to each other. They're linked to each other. So these two are going to, you got to look at the opposite for each other. So 1 and 1 gives you a 1, whereas for the OR, 0 and 0 gives you a 0. So you just got to remember that opposite. Anything else gives you a 1, anything else gives you a 0. Now, the XOR and the XNOR, these two are related to each other. These two are the opposite of each other. So, notice for the XOR, let me zoom out so you can see the name. Notice for the XOR, 0 and 0 gives you a 0, 1 and 1 gives you a 0. And then the XNOR can be the opposite. 0 and 0 gives you a 1, 1 and 1 gives you a 1, and the rest are going to be the opposite value. And then the NAND and the NOR are going to be the opposite of each other also. So the NAND is also technically the opposite of AND. Because if you notice the pattern, the NAND is the opposite of AND. So 1 and 1, instead of it giving you a 1, it gives you a 0, and anything else is a 1. The NOR is also the opposite of or. Because if you look at it, instead of 0 and 0 giving you a 0, 0 and 0 is giving you a 1. And then everything else is 0. It's very complicated. I know it's very complicated. Um, but like I said, I don't see it that much on the exam, but it's still good for you to know in case it does. You never know what could appear in your exam. Um, but I don't think they would give you XOR. Even if it does come, I doubt whether they can give you XOR and XNOR. It might mostly be not and an or. So if you don't want to remember everything, at least remember those three. But what can help you to remember is you just got to remember the concepts. Is that it can take you a while to remember, but it's relatively simple, but it can take you a while to grasp it. You just got to remember firstly that not is the opposite. You got to remember that first. Not is opposite. So changing 1 to 0, 0 to 1, the opposites. Now, why are you erasing everything? Now, when you remember, or if you remember the and, you can remember the NAND. Because the opposite of the and is the NAND. The end actually means not. These end that you see in here is actually not. So, if you notice, NAND is actually the opposite pattern of AND. These two are actually the opposite pattern. OR and NOR are actually the opposite pattern. So you just got to remember these three basic ones. Not is the opposite, and all one give you 1, everything else is 0. For the OR, all 0 gives you 0, everything else gives you 1. And if you remember that, you just do the opposite of the and it gives you NAND. Do the opposite of OR, and it gives you NOR. These here, you can try to remember them, but I would say, if you can't, if it's too much for you, just remember those three basic ones. All right, any questions on them before we move on?
No, sir.
But you guys think you understand them though? So let's look at an example as to how they are being used. So look at this example here. So this might give you an idea as to a real world situation of it. So this is your logic operator here, and now you have if mark is greater than 70. Now remember, this is a test. This is a question. So remember, it's either true or false. Same for over here. Is term equal to 3? Is that true or false? So, and we actually have another one here. Now, and then the statement continues, then display promoted and awarded a plaque. So, then, remember then is true. The then keyword is true. Else is false. So this is how all these things come into play. Else is false, then is true. So let's go through it. Now, if, say for instance, this one here is true, this one here is false, and this one here is true. The end result. Remember, this is the AND operator. The end result, is it going to be false or is it going to be true? Let me see if anybody remember. The end result,
It will give you a false.
it will give you a false. Right. It's going to give you a false simply because one of these here is false. So that's why I was telling you guys. So we can look back at the table. Remember, everything for the and, everything has to be true in order for it to be true. Any other pattern, anything else is going to be false. So with this here, simply because we have one false, the result is going to be false. So are we going to go to the next step? No, we have to ignore it because then is only if it is true. So if it was that this was true, Mark is greater than 70, and the term is equal to 3, and the person did get a rank less than 10, then the result of that operator is going to be true because all of these tests here is true. So what's going to happen next is that we're going to go to this then part here. We're going to display, promoted, and awarded a plaque. Anybody not following that? Anybody that was not clear on that? So you guys seeing how that truth table worked there? Are you seeing that? How true, 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 all equal true? Are you not seeing that?
Sir,
Mm-hmm.
so if you only remember for the and, right, you only need to remember that once all the statements are true, then it will give you a true.
Right,
Other than that, everything is false.
right,
And for the NAND, it would basically mean that anything that is true would give you a false, and everything that has a true and false will give you a true.
right.
Okay.
Or how I just remember it is basically switch up the values that all false, all true actually is going to give you a false. But it's basically the same thing you said. Whatever method you use to remember it, that's up to you. Let me not confuse you. But you said it correctly though. All right. Anybody
Okay.
else? Any other question? Yeah, so that's an example as to how that operator is used. We can look at this one here also, this AND operator. So if Mark is greater than 70, it was basically the same thing. So let's look at the OR now. Let's look at this OR here. So if Mark is greater than 70 or rank is less than 10, so if we do false and false, or false and true, what would be the results?
Sir, it would give you a true.
It would give you a true, correct. So for the OR, it's everything has to be false. Everything has to be false, the OR, everything has to be false for it to be false. Everything. Any other combination, the result is going to be true. So the simple fact that we have a true here is going to be true. So we go to this line here, then display promoted. So that there is resulting there. So if this here now was false and false, then the result would have been false. And we ignore this step here. Now, if you guys can remember, you actually used this operator already. Anybody can remember from where? You actually used it already twice. When you were doing spreadsheet and when you were doing database, you actually used it. Nobody can remember? Can you guys remember? Let me see if I pull it up. Um, Spreadsheet. Anybody remember the advanced filter? Remember the advanced filter, we did criteria, and we had two types of criteria. And we had the, anybody remember the names for the two type of criteria?
Sir, was it sort and filter?
No. There were and or. The same logic operators that we learned about right now. So we actually use the logic operators already. And it was the same concept when we were doing the advanced filter. So when we were doing the advanced filter, remember, if you guys can remember that when we were working on the and criteria, both had to be true. Can you guys remember that? Both had to be true for you to get a result. So it's the same thing that you're learning right now. Both have to be true in order for you to get a result. And then for the or, at least one has to be true. That's what I would have said. At least one has to be true, and you're going to get a result. And it's the same thing for the or. So if you notice, everywhere that you see in a one, there's at least a true there happening in this or here. So we already learned about this. We already used it in that spreadsheet case there. Yeah, I think that's everything there for those operators, those logic operators. Um, any question on it before we move on? All right, so let me send the picture before I forget. Yeah. All right, so if no questions, I'm gonna also send you a video on it too. That can help you also. So let's move on to the next chapter. Now the next chapter should be familiar to you. It's your trace table. That's called testing your algorithm. We call it tracing your algorithm also. So let's run through the paragraphs just in case I miss anything. So desk checking is the process of reviewing an algorithm for the correct processing and output. So that's why you're actually doing a trace table, to ensure that you get your correct calculation, you get your correct output. So that when you actually do the calculation manually, you will ensure you are creating the correct formula. Now, you do this by manually executing the steps in the algorithm one step at a time while keeping track of the results. So if you guys can remember from your trace table, that's exactly what you did. So we started desk check-in with example 12 by going through each loop and explaining the output. The logic of your algorithm is an important part of testing. Using a trace table will help you to test and verify your algorithm. An algorithm is a sequence of steps which seek to solve a problem. If you freeze the algorithm at any point, then you have a snapshot of the state of all the variables at that point. So basically what they're saying, um, if I had somebody's trace table, would have been good. Basically what they're saying is that if you stop the program, if you stop the algorithm at a certain point in time, that is what is going to be called the snapshot. And basically, you should be able to um, determine what values is at that step, basically. So, like for instance, so remember this is why we have the table running 10 times. Because remember the same variable being used over and over. So simply, say for example, we stop the algorithm at this line here. Then basically at this line, the variable at the top there is going to have a 2. Um, this variable is going to have a 0. This variable is going to have a 5. This variable is going to have a 2, and so on. So that's what we call the snapshot. That if the program does go on, it's going to have a different value. Earlier in the program, in the pseudocode, it's also going to have a different value. So as it stops at a certain point, as it's frozen at a certain point, it's going to have a certain value, a certain state called a snapshot. Now, the trace table is a very useful tool which allows you to see the state of your algorithm with as much detail as you wish. Each row of the table shows the state of one step in the algorithm, and each column shows the value of the variable at that step. The trace table allows you to check the algorithm for errors. So remember that. They might ask you that question in your exam. What is the purpose of the trace table? It is basically to review the algorithm, check the algorithm, check the calculations to see if they are correct, check the steps to see if they are logical, if they are in the correct order, check to ensure you're getting your correct output, which is all basically checking to see if you have any errors in your algorithm. So we can imagine it as a table, and these are your variables at the top here. So remember the variables go in the heading, and the values basically come down inside of that, in that particular column. So this variable quantity has a 4 inside of it. And as we go through the program, notice over here, as we go through the loop of the program, the next, as it goes around, it's going to get a 1. Sold is going to get a 1, then a 2, then a 3, then a 4. And it continues like that over and over. So we can look at this last one here. So at this stage, we can call it stage 1. Quantity has a 4 inside of it. Remember, we always look at the row. And Sold is going to have 1 inside of it. Invoice is going to have a 3 inside of it. Value is going to have a 14 inside of it. Then at stage 2, when the loop goes around, quantity is going to have a 4 still. 2 is going to be sold, and it goes like that over and over. Let's see. I think we're finished with all of those chapters there. Any questions on the trace table before we move on? Yeah, we finished with all of the chapter 9s there.
Sir, I have like a question. I don't know if anyone else wants to ask, but I just have a question because I'm curious. What time does this class end?
I think it's 8:30, and that's 7 o'clock we start.
I'm not even sure. I just logged in.
Yeah, it's not 7 o'clock we start.
Yes, sir.
Yeah, 8:30.
Okay.
All right. Well, you want us to end here? Because we did cover a lot of information, a lot of technical information. And next week we can start fresh with chapter 10, with programming. Anybody else? Continue. End there for tonight.
We can end.
The ranger. All right, we can end there for tonight because we still have a reasonable amount of time more until exam. And a lot of these information here, you guys already know about them because you did it practically. So it's not much of a content in that sense. All right, we're gonna wrap up here for tonight. If anybody has any question on any of the chapter 9, you can let me know. Flowchart, algorithm, trace table. No questions? Enjoy the rest of your night.
Bye, sir.
Goodbye.
Oh, you have to text me, right? I have your work.
Oh,
I finished it.
congratulations.
I think it's too long though, because I wrote 3 paragraphs.
Once you have the information that I told you, that's all. It doesn't matter if you have too much or too little. Once you have those specific information.